About TTN nesting software, let's first look at some. First of all, this is the configuration of the computer. The system processor is a computer, memory storage capacity of a hard disk, memory. Now, we need to install a decryption tool. This is the installation step of the decryption tool, and then we follow this from step by step is to install it. So once we install it, we can look at it. We can here see there is the authorization code. Enter the authorization code we received and activated it. In this place, you can see the date of the authorization. We can only use TTN typesetting software normally after installing description tool and obtaining authorization. This is a SolidWorks interface. So when we first install, we are going to select TTN here. Let it load in before you can use it. Let's import a graphic and take a look at two features that come with plugin. We will talk about this later. When we enable TTN, this place have an enable. And if I click on it, I'm going to go to an interface for TTN. And this is the coordinate system. X-axis, Y-axis, and Z-axis. This is the save and knife path settings. The first thing we see after we go into the two path settings, the first thing we see is output path. This is the setup for the output code directory and the output report directory. Its code is that we export after we design the program, the report that we want, a path that we store. This place can choose where to save it. Then, this place is languages which are currently supported. Then there are two different options. One is to use the part name, the other is to customize the part name. When you use a part name, then the code report directory that is stored, its file's name is the name of your. When you use the custom part name, it exports the code and report the name that you type yourself. We can take a quick look at this place. Using the part name because it's just a graph, it hasn't been processed in advance. So let's do a process on it. Generates the path, so it is processed by TTN. After processing it, we will see the sum of the other functions are now operable, no longer gray. When you output a report, when you export the report, it automatically pops up. This is the folder where the part is stored. This is the name the part we used a report exported. And then we change it to custom. This is where we can type in the name of the part of the report that we want to save. I can see this part. Its name is 123, which is I just type in. This is the setting of the file output path. And then let's see. Some setting for cutting. The first pretreatment, where there is a minimum string length, arc tolerance, and slip compensation. The length of this minimum string. Because our circle is not circular data, it's a circle of very small straight lines. So it's made up of a lot of very small line segments. The length of the smallest string, which is smallest length of the little line segment divided by the path. The smaller it is, the smoother the circle will be. At a minimum, no less than that. The tolerance of an arc means this path we are cutting, he's taking a very, very straight line. The maximum distance between this very small line that he's working and the top of the circle actual slit compensation, because when we do laser processing, he will have a slit. Then this slit will affect the dimensional accuracy of the part we cut. Different thickness, different materials, and different cutting methods. Their slit size is different. So we can accurately control the size accuracy of the part we want to cut by adjusting a compensation amount. This is the weld compensation. Weld compensation, which is used for our pipes. After the two pipes are machined, they are sliced together. Just like this picture, we can cut a oblique around the hole in the wall of the tube, then insert a round tube into the hole. Because it is affected, when it inserts another tube, this is some interference of the other side. So we need weld compensation to get rid of this interference. So this will ensure the shape of the circle that we have created. We can insert the tubing that we want to combine. Weld compensation, it comes to in two ways. One is biggest cut and one is smallest cut. And here we can see the way it shows the contour cut. This is the minimum area cut. This is the green line. It's going to be cut a little bit more than the circle that we drew. And the extra cut is the part then contain the other side of pipe. So that the hole that we cut can be directly inserted into the pipe. And then there is we can see that outline he's working on. The smallest outline of the tube is working on. With these kinds of processing, you cannot just stick, but you can adjust through some tools. Five-axis knife path, that is, the cutting head we can swing, can cut the slope of the effect. Look at the picture. Let's try it with this diagram, which we are going to attach to a tube. But it has a wall thickness. Generate the toolpath. The green line is cutting an angle formed by our cutting hand. When we cut the cutting hand, it's vertical, and when the back side of this tube is also vertical. That way, it's going to be a little bit smaller than we are actually drawing. There's no way for it directly fit the outline of the outer wall of the pipe. If I look at this place, there's no way for a vertical cutting head to cut the slope. We add well compensation to regenerate the cutter path. After regenerating the knife path, he will cut this part out. He follows a path that follows the dimensions and contour of the wall. It keeps the size on the inside of the wall constant. And then when you do it, you can make sure that its accuracy fits to the outer wall of the another pipe. So it compensates for this pipe, for the inside part of the pipe. If you look at the configuration to the knife path, in the configuration of the knife path, the cutting leads. The first, the position of the lead. It can have a choice of several positions. Let's import a graph. Set the position of the leads, the direction of the lead. This is the introduction. There are two ways to introduce. One is straight line and one is an arc, which we will show you later. This is the side of the lead, so let's make a little bit bigger for observation. Actually, processing time subject to your needs. So let's take a look at that. Generate a path. This place is a lead. The green one is the lead, and then we switch it to the right. If you look at the coordinate system, this side is in the left side. Now all the leads are on the right side. They are all on the top. Specific lead position can be adjusted according to the actual processing situation. See which side. And then I went to adjust it. There are two forms to introducing lines. One is straight line, the other is an arc. And instead of an arc, it creates from the lead into the cut profile. Of course, the size of this arc can also be set. It's going to be a little shorter than that. Lead. This place sometimes when we cut parts, it will leave a connecting point or overburning point at the starting point or cutting the point. If there are connection points and the workpiece does not fall off. In this case, we can solve the problem. You can see there are two types of axis line. One is a straight line, one is an arc. This is the lead line. This is the leading in line. I can change this angle, add an arc. So the leading in the line of an arc, the leading out. What is the difference between the arc type and lead, the straight type lead? If it's a straight line, it cuts here. And then when it starts cutting the contour of this workpiece, let me start cutting the workpiece. So this pose sometimes will create an overburned mark in this area. If this an arc, it's going to move smoothly. So it's just a slow deceleration. There's no noticeable pause. So the lead in, lead out line displays of a process is certain help. Take a look at this. The cutting phase leads are introduced near the truck. If you look at this graph, this is one of the location of our truck. And then I introduce this part near the truck, which is this place. This outline of the knife, which is near the truck. The contour here is close to the truck, and then in these two places are to introduce. Let me draw a little bit more visually. In this case, our truck is on the left. You can see this outline. This side is close to the truck. This side is away from the truck. If I enable this side, introduce near the car to generate a knife path. In this way, you can see the outline. This is the position of the contour, which is close to the truck, so it adds to the leads to the cut the contour. He would have put the fuse right here. Instead, the cutting surface lead is introduced at the end limit. Let's switch it over and see what it looks like. You can see that if you are. So at this point, it makes an introduction when the contour of the part that. So this point is going to make an introduction. The biggest place. The cutting surface does not automatically. The function is that when we cut the face, Sometimes we don't have very high requirements for the end phase, so then the two parts are joined together. If we add a lead, it's easy to burn this time here, so we check it. And the end without adding leads. In this way, at the end position, there are no leads. This option does not affect the addition. For example, I have some contour to be processed in this place, and these contours are normally processed after you check the function of the leads. This function is only work on the end phase. And then we go to the next one. Microdrawn or overcut, two ways. One is this tiny connection. This is the function of the micro connection. That's how we cut from the beginning to the end. A section will be left without cutting to prevent the workpiece from falling and remaining on the place. This is the reserved size. Take a look. This is the starting point. And I'm going to start cutting from here. And then after I cut this outline, after I cut around. This is the end point. This gap in the middle, which is not cut. Thus, we leave a little bit uncut and add a micro connection. And the size of the micro connection is the size. This function is that if we are there are some parts after we cut, there is not easy to collect. So we can use this function to leave it a little bit uncut. After this is done, it can be collected as a whole following the sheet. Let's take a look at another feature, overcutting the contour ends. Overcut is different from the microdrawn that when you overcut, you start the starting point, then you go back to the starting point. It already took cut the entire contour. Because sometimes, especially with the tubing, when the walls are thick, we cut straight from the beginning to the end. If this place is affected by some cutting technology or the influence of the plate, so we get him to cut a little bit more to make sure it falls. The next feature, micro connections. Let's do another graph. To enable the micro connection. It was when we were working with the cut contour. It will automatically add a microlink for us based on the parameters we set a size, quantity, distance. Microjunction is when you cut into this place. The cutting head will top the top light and then top cutting and then go to the next position. The workpiece will leave a little joint. There's a connection. Apply micro connection. Add micro connections. There are several ways. Number, distance. Several types. More on that later. We select the quantity, we automatically add a micro connection. For the size, we will make a little bigger. Quantity for distance from this place. If you press quantity distance from this place, there is no way to choose it. The length of the minimum edge to generate the knife path. At this place, the blue line is where it adds the micro connection. He's going to take all of our contour and add 4 micro connections. And the size of the micro connection, which is the size that we just set, is a little shape because it's too small. All 4 connections are squeezed together, and you can change this place the size. The size of the hole didn't let him add. When you set the length of the smallest edge to be larger than the size of the hole, it doesn't add micro connections to you. In other words, the length of this minimum edge, which refers to the minimum length requirement that we set for the micro connection. At this length, a micro connection is set. If it's smaller than the length, the micro connection will be. If you look at distance, if you choose distance, there is no way to choose quantity. This place is distance. Add a 3 micro connection at 30 millimeters intervals. So it's only have 2 micro connections instead of. Then add micro connections. It's going to add micro connections to us at this distance we just set. Add a micro connection to the lid just like a micro connection. And then in the lid should be the position of the lid. Leave an uncut distance, which is considerate. This place, where the lid starts after the cut, it doesn't cut at this point. Angle R is not micro-connected. This R angle is not micro-wired. And as it calculates, there is a little connection right here in the arc. Sometimes the micro connection may be added to the R angle here. If I add it here, it may affect. So when we select it, when it calculates, there is a micro connection to be added to this position. It will not add a micro connection, but it will add micro connection somewhere else, including the end face. When we add a micro connection on the end face, this R angle right here, when it's going to go through R angle, it doesn't add micro connections. When you check it, it's easy to check when you add micro link to butt cutting. It ensures that micro connection does not get stuck and awkward. Let's go to next one. Down here is a setup of a lid. Advanced knife path configuration. A lot of functions processing, especially some special profile, are in this advanced tool configuration options. Select the configuration of the section. There are a few different profile options. Different profiles, and then it just the setting of some parameters are different. I'm going to leave that for later, but it looks some of the other settings. The first one, the slender cut. Let's import a drawing to make it more intuitive. This place, when we draw, what we need to do is a cut very slant of this tool. There is no guarantee that this line will be cut well, because we just want a line here. At this point, we can do with the thin strip out. This is the maximum width of the thin strip out. Enter a number. When the width of the contour is less than the value we set, it's going to default the contour to a line to cut, and we look at that. He cut through here, and then he cut through right. If you look at the simulation, maybe it's a little bit more intuitive. He would just cut a line right here. One line, just one cut, instead of having to follow the original outcut. Take a look at this. At this point, these three letters, like this one, is contoured, but they have the ability to cut through the outline, which is default by makes the outline just marking mark. He cannot make the outline that we cut. It cuts right through it. It will treat it as normal cutting contour or select the corresponding cutting parameter based on. I just cut it off. And when I check it and I turn it to this color, I made this color. Such contour without penetrating tube will be used as marking contour for marking processing. Both are selected by default. To apply an empty stroke in the length direction, you can look at the stroke shown here. When I down select him, he finishes this. Its cutting speed is very slow, and when you have very long pipe, it's very efficient. When he finished cutting, and then he's going to next contour to cut, he's going to add a speed of air freight. It's a lot faster, and if it's normal place, we will default to it. Detect the surface profile of the pipe. Let's do another graph. Let's see. This figure and the uncut contour are marked. What is different? It identifies the uncut outline and identifies the sketch outline are marking. We can look at this graphically, but it's just a look. If we look at the graph, if you look at this place, it has thickness. This place have a thickness, but it not penetrate the wall of the tube exactly as the outline of the square hold it. This is the uncut outline by default. So when we select Identify to uncut the contour, the default one have a certain thickness. It has a certain depth. By contrast, this color is marked, but here the contour is not processed. So let's uncheck and identify. If you look at this again, it's going to be treated as marking. This is the difference between the uncut and sketching. The end profile does not generate a cutter path. Sometimes the length of our pipe is the same as the length of our part. There's no need to process the end face, only need to process the pipe. We can select this option if you can look at this end face. The original path, it had this green path. With the end face, it won't be processed. Avoid perforation. Let's do another graph. This place will have a sloping 45 degrees slope. Let's see. This place also has a slope, and then both of these places have slopes. There is a slope here, and it forms the side of this slope. When I check it to see the difference, let's see, both these perforations are on this side of the slope. When we select this, it will be on these two straight edges. Avoid perforation. You can see this form from this graph. This surface is a 0 degree. And then when we want to make a punch on this 0 degree plane, it's all my punch. I'm going to put it on the 0 surface. I'm going to pick this one and punch at 0. He would put a perforation on this 0 degree plane. Next, the cutting surface surrounding holes are cutting this surface surrounding. First, cut the surrounding. This usual way. After cutting the hole, then cut the end face after cutting, because this hole is very close to the end face. So sometimes there may be some error in this side of the hole. So the cutting effort is not very good. So when you can cut through these 4 holes first. There are 2 more and the opposite side, 4 holes in the total. You can use it. Cut the surface around the hole first cut. Look at this cut path. Let's see, this is the cutting the face. And cut the face and then cut the hole. Let me reset it. Cutting surface surrounding hole. Generate knife path. You can take a look. Now the change in the cut route. So when it's done with this hole, it's going to go straight to the opposite hole. And then the cut middle section if you have some requirement for holes. If the accuracy is high, you can use this function. Fixed trunk rotation angle. How does this function work? It's that sometimes we have something like this unusual type of tubing. And then because the shape is not very regular, so when you generate the contour, and during the whole process, the cutting hand might have some shaking or some touching. The cutting process is not so smooth. So for this unusual type of pipe, you can use this to fix the rotation angle of the truck. If I set it up, this is the minimum length. This means that the length between every two normals cannot exceed the maximum segment length value. I'm going to generate a path. Let's see. When it's cutting hand through the irregular outer wall, check chuck side rotation, cutting hand side movement, especially in this place. Chuck side rotation. This fixed truck and rotation angle every time the truck rotates. It's not more than 5 degrees. And then the minimum length at this place right here. The length between these normals does not exceed 5 millimeters. Let's see the maximum angle span of the truck. This is 45 degrees. That is where the truck is when I cut the corner. If it's going to beyond 45 degrees, and then it goes back to the next set of the controls. In other words, well, within 45 degrees and the truck within 45 degrees, and then each time this rotation of truck will not exceed this degree. It doesn't exceed the degree of the rotation that you set, which is applies when you are cutting a shaped tube. Rounded corners, irregular shape like this when you cut. Add a segmented control to make the whole processing more stable. We can look at this. Look at this place. Its normal line very uniform. so its motion is very smooth. This can ensure that the cutting effect of the end surface. The edge material. If you look at this function, if we look at this part, if you cut the hypotenuse directly, it might not cut very well. If you look at this cut path, it cuts directly like this. If I cut this one, and then I just cut the next one. Let's use this function and see. You can see that in this one, it generates a vertical cutting surface. After this, I cut this part and then I'm going to cut the surface vertically like this, and I'm going to cut another part. This is the vertical section. It's like every time I cut a piece, then I'm going to make a cut, I'm going to vertical cut. Because this place for the sake of the cut here, is going to cut off this end face. There is a margin for protection. If there is no margin for protection, if you cut directly, the short edge might not cut very well. And then the following edge loop inverted. It's the same, this one. The next feature. There are some contents of advanced knife path configuration. It's mainly the processing of trajectories. If matched with appropriate process parameters, can play a very good cutting effect. So especially when you're working on something irregular, or something special. These parameters in advanced knife path configuration can bring a good cutting effect. This place can be adjusted, and the process of doing this. Let's look at the difference. First, model section, because there are many tube cutting models. Therefore, it's necessary to choose the model of use here, and then the configuration. There are two models for the choice for the process stream. One is speed, one is standard. Here, if you choose the speed, when the cut angle R equals the parameters of cut layer. The standard stream is a parameter. Whether to cut the Z code. Code to simulate. Now the output of this program simulation has no Z-axis data. Let's take a look at next one. Does it support leapfrog? If it doesn't have a leapfrog function after he finishes cutting the contour, his cutting head goes up to a set height. After the chuck rotates around and then the cutting head comes down and it cuts. If I have leapfrog, the cutting head will lift up a short distance to jump to the next. In the process of lifting, the truck will carry out a coordinated rotation. Truck and cutting hand lift. That way, it saves a lot of time, and the simulation does not necessarily show up. Maybe it's hard to see, but when it's done. Cutting hand short distance up. Truck began to turn. Short distance to the next figure cutting. This is frog jump. Let's go to the next feature. Rather follow the support. For this place is actually divided into models because different models its function for this follow-up is not the same. And then I have to T-axis, O-axis. This plays according to the actual situation for the machine tool as well as the situation you want to process pipe to choose. For example, if the pipe is very long, the whole pipe will have some deformation and droop. So you can use this follow-up support and then so that during the cutting process, it will support the pipe. Ensure the pipe is a horizontal plane to reduce the impact on the cutting effect. Whether to turn on the flight cutting. There is no way to see in the software, but you might see in the practice. If just after I cut this salute, if I don't do this flying cut, it's the cutting hand, and then go to the next contour, cut again, and the cutting hand goes up again. Cut another contour and go up again. Cut another contour. When you check it and turn on the flight cut, after he finishes the cutting the contour, and then the cutting head does not go up the height, it will be at the cut height. And then quickly jump to the next figure for cutting. These circles are processed as a whole. In the process of machining these circles, the cutting hand always cuts directly at the cutting head. For the parts like that, there have a lot of round holes, cutting efficiency can be improved in this way. Let's look at next one. Pipe deviation compensation. There are several options here, no compensation, manual add and automatic add, because the outer wall of the pipe is not necessarily regular. It might have some deviation. So when he is cutting affected by this area ever in the outer wall, so then sometimes the square hole is in the middle. It might divide it from the middle. It might divide it from the left or to the right. At this point, we can use this function. Tube deviation compensation, and then he corrects it the way he worked it. When he finished cutting the hole, he starts cutting the second one. After you cut that hole, go to the next hole. The distance between them is more than 1,000 millimeters, so he has searched again. 4-point search, find 4 ends, and then a center correction after rectifying, and continue to cut the hole. Every meter, it goes through this central alignment. And then the next step, whether to use an 8-axis fast. When we cut one contour, and then we cut the next contour, the track rotates. And then the x-axis and the y-axis are going to be moving. And during the motion, this speed is set in 2 places. One is the speed setting of the device itself, and the other is the setting of it is our cutting software. If you choose yes during this space lifting, that is, it's going to move at the speed that the device is programmed to move at. If you choose no, it will use the cutting speed set in the software to move. In general, the default is none, which will be very slow and inefficient. The rotation speed of the truck. This place is a speed limit truck. Sometimes when we cut, some pipe fittings are small, or when the pipes fitting are large. If the speed is too fast or too slow, it will have an impact on the cutting effect, so we have to limit it to situable. You can adjust by typing it here. That is, no matter how fast you cut, the speed of your truck will always be within the range you set. The lifting height of the z-axis is a time compensation value for the lifting height of the z-axis in the cutting process, because its z-axis evaluation height. It used to for some angle steel or channel steel, some non-closed pipe. It's irregular, and as it rotates, there are maybe some collisions with cutting head. You can use this to set up a compensation for the z-axis height, so you can avoid a collision. Blanking delay. This is when it finishes cutting a part. By the time you start cutting of a piece, there is delayed. For example, we might cut some of the tubing. Manual assisted unloading may be required, which may take relatively. There's no delay. It's easy to happen some dangers, so we can adjust the delayed time appropriately. During this time, we can do some blanking or some electrolytic actions. Some of these parameters in the post settings. After settings is more inclined to some action adjustment of the machine tool. And this tool path setting is inclined to action of the machine tool and a processing method combined with the process. If you look at the auto sort, the first one, area length, angle tolerance, X tolerance. Sorting settings, Z bow. There are also sorting options, sorting by part, sorting by cut type. Import a drawing and look at it. Change its parameters. And then let's see, I change it to 40. Let's look again 2 holes, 4 holes. Cut 4 holes in one side, then change again. Cut 4 more holes, change again. Let's see, let's change the numbers. He now starts with 4 holes and then turns. Cut 6 holes. In fact, displays the setting of these 3 values is to divide to contour to be processed on the pipe according to a set area. I cut this area first and then I cut the other area. It's divided by region and then is the length of the region. In the range of how long, and then this is A angle. In the range of how much it rotates. He would default to appropriate area, and then after finish this area, he would move on the next one. Another area within this size range, and this area right here, is tolerance value. There are parts and might be right the boundary that we set for this area. So he needs this tolerance when the size of this contour is on the critical line. Now the length of the area is 120 and the tolerance is 5. And when the contour is right on the 120, but his is within 125, so it's default to processing in the previous region. If it's greater than 125, he would default to processing in this area in the back. In this place, is the path of knife. What is the path of knife for this kind type? It's a Z or a bow. That's very obvious. Sorting by the part, that sorting does not consider the progress of making, marking, and cutting according to the sorting area set. As long as it's within this range, it will give progress to. So this is the sort by part. Sorted by cutting type. Some pipe may have both marking and cutting. Then you can progress the marking and then cutting. It sorts like this. And this sort, when you're actually using it, you can see. Let's go to the next report. The first output part image. This is to display the part to image in the report. The second is to override the div. The third is to generate NC and report at the same time. Generate port at the same time, also generate. The port is generate. The first is to regenerate, separate. Second, all the nesting material generate a statement because reprocess. He might have a product. He might have many type of tubing. He might have a round tubing. He might have square tubing. Then there are different sizes between the pipes, and then the same size, the same type of pipe. You can end up with multi-pipe sleeves. So when the output report, it can choose each type of nesting output at a separate report. You can also select all types, all size to generate a total report. This is the name of nesting, the default nesting. Using report names. When nesting, it will have a nesting file name. This one can be set together. We can generate a report and look at it. This is the self-named one. This is the tube test row is the name. Its size, the size of part, the number of nesting materials. The data. Let me draw a graph. It's just to make a little bit more intuitive. This is the body. It has different tube, different length, and that's what the software recognizes. And then one of the names, quantity, type of tubing. How many different types of tubing are there in the set of parts? can make an identification. There should be 26 types of tubing. Look at this. This is the one it covers. Different tubes. It will generate a separate list of nesting material for different size. In this place, there are 5 types of nesting. Each nesting material can generate a separate statement, or 5 nesting material can generate an ununified. This it if set separately, it will generate a report for each nesting material. According to the list of their own set statement, and then to choose it. Okay, now let's look at the next feature. When we create a new working interface, the nesting function is only available under the interface is assembly. If this is interface of the part, it has no. You have to create an interface for assembly. This is an assembly. And then we import a part. Import a part. This is the separate part. It does not have the function of nesting. New assembly. This is the part that we just had. We can pull it out. Let's see this number of the part and the other information. You can set up here. And if you look at this table, the number is 5, and this is the set. And what this set means, all of my parts, all of the parts that I import. So if I wanted to cut 5 of this, put 5 here, it would multiply all the parts in the list by 5. So when you finish setting up the material, you need to identify the parts. After identification, the nesting task is generated. generate a toolpath for automatic nesting. As you can see, the automatic nesting has been completed. We can also see the information about this place that the length of my pipe is 6 meters. And then I set 25 pieces using 1548 millimeter. And then the length of my tail material. In the nesting interface, we can look at the nesting settings in the knife path. This place of my way is nesting. It's divided into two kinds, fast and advanced. This one is the progress of saving. Fast mode and safe material progress is only suitable for simple. Because the calculation is relatively simple, so it generally has a shorter nesting time, and then this place is some setting of the common edge. This is the length of the tail. This is the spacing of the parts. What's the difference between the two parts? This is the distance between the edge. This is the difference in the thickness of the pipe, and the difference in the thickness of the pipe, the outer wall of our pipe. Its actual size may be larger or smaller than the standard size. Here we can set a thickness tolerance of the pipe, which means the actual pipe, the thickness of it, whether a little bigger or a little smaller. As long as value is within the tolerance range, it can be used at this type of pipe by default. This is common edge tolerance because with common edge, its two parts struck together. As long as always stayed within this common boundary tolerance. It gives you common edge by default. Because sometimes when you draw a drawing, it might not be straight line. A little bit of an angle, so they are opposite each other. They are exactly combined. There may be a little bit clearance, but as long as the clearance is within the tolerance range, it is delectable. Take a look at this. It has gap in parts. It would be a common site, and we could do it in another way. It's more advanced way. Common edge cutting. This is the common edge cut. This is the island common edge cut, and there is 4 axes compensated. The way common edges are, we'll talk about this later, but let's look at an effect of common edges. I'm going to regenerate the tool path. Let's take a look and regenerate the nesting cast. If you look at this, it's strange the way it is arranged. So he paired the strange edge together, and then he will pair the empty edge together, first of all. Second, its processing efficiency will be relative high. It just have 1.5. This place is material software. Here's some information about material library. Here is a standard size pipe of 6 meters if we want to add some of our lengths. I can add a little bit of. Add input size, pipe name, thickness, quantity. So once we type in, let's look at the current one. Generating the nesting task. He's going to take this of two 700 lengths of tubing that we. Once you cut it, you are only using 6 meters of pipe. So if one add part, we can set it up from here. This is the casing. Let's look at another quantity. Look at this one. This is body. This is all the parts in the body and how many the same parts are there. And we put the number of sets we want to process, 2 sets, and you can see the number he sets becomes 2. And then the number of the part will increase based on the number that set you have identified. The drawings are complicated. Generate nesting task. Generate a 2-path automatic nesting. Seven strings. This right here, this is the length of the material. And then followed by the amount of the material used, 2. It uses 2, and then the following is 1. The default is 1, and this is what it looks like. Material reset. This is the interface where we just entranced the quantity. The content of the nesting material is probably this. Thank you for your listening.